Welcome to Eugenius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects. Hello guys, it's a great pleasure to be with you again. In this video, we shall look at the discovery of the atom's nucleus and Rutherford's experiment. This topic is covered in the first unit of Senior 4 Chemistry according to Rwanda Education Board curriculum. The unit is Atomic Structure and Mass Spectrometry, and the simulation is Rutherford's Experiment. It's Ernest Rutherford's Experiment. Let's have a look at the objectives. At the end of this video, you should be able to describe the discovery of the nucleus of an atom and use a simulation to explain Rutherford's experiment. Why did Rutherford carry out the experiment? To answer this question, let's start with the atomic model, which was in use at Rutherford's time, which is called the Plum Pudding model. Thomson's Plum Pudding model. Thomson is the scientist who suggested this model. So in 1897, this English scientist, John Joseph Thomson, provided the first hint that an atom is made of even smaller particles, and those particles were called electrons. He suggested that an atom is made of positively charged substance and some negatively charged particles which are scattered in the positive body like resins in a pudding. We can also take the example of a watermelon. We know how the seeds are scattered in the whole body of the solid watermelon. That is the same as what Thomson suggested to be the model of the atom, with a very big part of the atom which is positively charged and some other very small particles which are negatively charged and which are distributed all over in the body of that positive part. So the objective of Rutherford's experiment was to test if the suggestion of Mr. Thomson was right. Was really the atom composed by that big part, the solid body which is positive, embedded with negative small particles? That is the reason why Rutherford carried out the gold foil experiment. So in 1908, Ernest Rutherford carried out an experiment. And as I said, the purpose was to check if the suggestion of J. Thomson was right. Rutherford's experiment involved firing a stream of tiny positively charged particles at a thin sheet of gold. And that is what we are going to see using the simulation. Let's start with this part of the simulation which shows what would happen or what will be the outcome, the observations of the experiment if the atom had a structure like that one suggested by Thomson, the Plum Pudding model. Here we have the alpha particles. There is a source of alpha particles. Remember, the alpha particles, they are like the helium nuclei. If they are nuclei, we know that nuclei are positively charged with a mass of 4 atomic mass units because they are the helium nuclei. And specifically, we call them the alpha particles. So here is the source of the alpha particles. Here we also have a body which is representing the atom under the Plum Pudding model proposed by J. Thomson. And here you can adjust the speed of the alpha particles. You can also show the traces of the alpha particles while they are moving. We will see how it looks. And here you can reset. If you have been changing these settings, you can reset. When you hit this button, you can reset. And here you can start the experiment and the particles start to move, or you can stop them. Now let's start. Here we have the source of our alpha particles. You hit the blue button and then the alpha particles start to come out. You can see here we have a small hole so that some of the alpha particles which may pass aside the Plum Pudding atom here will be blocked by this thin sheet. Okay, and only the alpha particles which will be able to pass through the hole here are the ones which will be allowed to move through the atom we have here. So let's start. Hit the button. You can see the helium nuclei. Helium nuclei with a gray color and a red color. You can see the legend here. This one, which is almost blue, pale blue, it's the electron. It represents the electron. There are these ones, the small particles in the solid body, which is red. We have protons. You can see the protons in the alpha particles. We have neutrons. They are also there, the gray ones. And this particle as a whole, it's an alpha particle. And then this body, the red one, is the positive body, the positive charge, according to Thomson. Remember, I said that you can adjust the energy of your alpha particles. Here we have the minimum energy. You can see that they are going slow. And if you increase the energy, they move faster. You can also show the traces. You can see the traces. How are they moving? Now, let's analyze the observations we are making. This is what could happen, what could be observed if the atom, if the model of the atom proposed by Thomson was correct. You can see the particles are moving straight. Remember, we have negative particles embedded in a solid body which is positive, making the whole atom negative. So our alpha particles, which are positively charged, would go straight through the atom, which is neutral. Is it this what Mr. Rutherford observed? Is it really this observation that he made? So let's move from the Plum Pudding atom and we go to Rutherford's atom to see what happens, to compare the two experiments. Now, with the Rutherford's experiment, you can see that we have some electronic shells. We have the electronic shells here. We have this small body in the center with a yellow color. This is representing the nucleus. You can see here on the legend, it is the nucleus, this one, and the discontinuous lines, circular lines, these are the energy levels. And then we will have the alpha particles, which will be moving when we will start the emission of the alpha particles. Still, you can change the energy and you can also show the traces. Here, there is something new. You can increase the mass by changing the number of protons. And remember, when we change the number of protons, we don't increase the mass only. We also change the charge. You can also increase the mass by changing the number of neutrons. This puts it down, decreases the number of protons, and this one will increase the number of protons. This will increase the number of neutrons and decrease the number of neutrons. But you can also use this button. You can slide this button. As well, you can reset everything. You can reset, you can see it is reset. Now, here it is set to 79 because Rutherford used gold foil. He used a gold foil. So a golden atom or an atom of gold it has 79 protons. Now let's start the experiment. We hit on the blue button and then the alpha particles start to move. You can see here we have the traces. Now you can see something very unusual. You can see something unusual which we didn't observe in the experiment with the plum pudding atom. You can see that some of the alpha particles, they are being deflected from their path. Some of the alpha particles are being deflected from their path, but then the majority of these particles, they are going straight. What happens if we reduce the mass? If we reduce the mass, still the particles will be deflected, but the deflection decreases because we have reduced the mass, but as well we have also reduced the charge. And you can also reduce the mass dealing with the protons. Even that will have an effect on the deflection, the degree of deflection. But then before we go deep in the effects of changing the mass and changing the charge, let's analyze why we are observing these deflections. Before we analyze the deflections, let's have a look at the use of the nucleus only. Using the nucleus only, you can see that the particles are being deflected, the alpha particles, but of course, many are passing straight. So what could be the reason of this deflection? Remember, this is an experiment which was being done for the first time. So as an explanation to this observation, Rutherford suggested that it is possible that in the center of the atom, there is a very massive small body which may be carrying the same charge as the alpha particles. To mean that that small body which is in the center is positively charged. As we know, the particles which have similar charges, they always repel. So if some of the alpha particles are being repelled, are being deflected, it is because there is a small portion of the atom which carries the same charge as the alpha particles, and then they generate a repulsion. And because of the magnitude of this deflection, Rutherford deduced that almost all of the mass of a given atom is concentrated in that center. And then he called that center the nucleus of the atom, which contains almost all of the mass of the atom and which is positively charged. And from that, he said that the hydrogen atom, which is the simplest atom, has a single particle which carries a positive charge, and that particle was called a proton. So this shows that the suggestion of J.J. Thomson was not right. Instead of being a solid body, which is positive, with some negative charges which are scattered in the body, we have an atom which is composed by a very small center, which is positive, containing almost all of the mass of the atom, and the remaining part of the atom being almost an empty space with some energy levels or the electrons which move around that nucleus. Okay? So let us reset, and if you have not understood what has been explained in this video, you can replay and replay again to get a better understanding of what we have been learning today. So this is the end of the presentation, the Rutherford experiment. Now let's explain how you have to take the quiz whenever you will be confident and feel like you are ready to take the test. Here is the quiz code. When you are done with the video, you understand everything, you can try the quiz. The quiz code is VID 001004. And for those who have never used this assessment tool, let us tell you how you will take the quiz. You go to the website www.opanda.xyz and click on login. After that, you will click on take the quiz. You can see it here. It is marked with a tick. After that, you will write the code in this area and then you take the quiz. Thank you for watching. See you next time for another video.